For part 2, I've created the Simulink model and will be explaining it in this video. I will upload the project to Google Drive so you can all have access to it. I created the model in advance to save time. I will now explain each of these blocks in detail. There's also a MATLAB script here, which I will go over. And later on, I will add the VRML file to this model and show you guys how to animate this object in the world which we made before in part 1. So the clock here, it outputs time, the value of time, and is needed for input into this if statement. The if block states that if time, or U1, is less than 5, perform this action in the if action block next to it, else perform the action in the second if action block, which is below. The force table is used when the time is less than 5 seconds, as you can see here. The force table is saved into an Excel file titled data and is loaded by the MATLAB function called run_first. The code will be included in the file upload. If time is more than 5, switch the force to -45 newtons, which is below, and this will bring the object down towards the ground. The sum block, it adds the two force values. Keep in mind that the else statement only activates when the time exceeds 5 seconds, hence it is 0 before or not true. So once time exceeds 5 seconds, it skips the if statement and goes direct to the else, and as a result, the first condition becomes 0. So that means that using the sum block is appropriate. This block in the middle, it represents 3 degrees of freedom, forces in the x and z, a pitching moment which points towards the y-plane with the right-hand rule, and this can be written as my. The g defines gravity, which I set to -9.8 meters per second square in the z. And I use the body fixed mass as the force is assumed to be increasing here. So this would mean the same thing as the variable or decreasing mass with a constant force. The outputs represent the attitude, the angle, rotational velocity, rotational acceleration, the position on the xz plane, velocity in the x and z directions, and acceleration in the x and z directions. If you double click on the block, it opens this window. I have set all the initial values to 0 except the position, which I will change after to match with the VRML file, as well as the mass and inertia is obviously non-zero. The demux block splits the signal into x and z values only. And as you can see at the right, the simulation will stop when z is less than -20, and this block is used called compare to constant. So I have this Excel file here. Now these are the values of force. The column on the left represents time, and the column on the right represents the actual force value. Now this column only goes up to 5 seconds, as I said. The run first script on the right, the value of h reads the file, which is called data.xlsx, which is the extension. The column in is the first column, and the column out is the second column. If you double click on the force table in the Simulink model, it opens the window on the bottom right. Now the vector of input values is the time, so that should be in. The table data is the output data, which is out. And the lookup method is interpolation, which is just pull stuff out from the Excel sheet. Now I'll show you guys how to move your Simulink model and link it to the VRML file which you made before. So first thing I want to do is type in Simulink. It should open this window here. Find Simulink 3D animation. If you scroll down here, it should be there. And drag VRSync into your world. Your model. So out there. Now let's add the VRML file inside. So double click, find your file, click browse, go to your desktop in my case, and click launch_video. Now we can set the sample time to 0.02. It could be anything else, but it's preferably this value seems okay in most cases. Now find your rocket transformation file. So that's the node which allows you to move the object. And if you don't have it, make sure you go back in your VRML world and double click on your vehicle to activate the node. So click on Group, Children, find it here, it should be there. Now we're not going to rotate the object, just translate it. So click on Translation and hit Apply and hit OK. And now we can see that there's a node here. But it's not done yet. Now we need to add a signal expander. Now keep in mind that the translation is a vector in X, Y, and Z. But this block only moves in 2 axes, so only on one plane, right? So only on X or Y or X or Z. Now, I said before in part 1 that positive X is to the right, positive Y is to the up, and positive Z is towards you. So you want to find something called the VR signal expander. Now what this does is that it converts any number of axes to a specific axis. So if I be more specific, let's try this. So your output width, right? So your output width is your X, Y, and Z. So that'll be this. And your indices are the values which you want to use. Now we'll be simulating in Y. So in MATLAB, the Z points up, but in the VRML, Y points up. So we need to add 1. Let's try adding 1, 2, and 1 and 2. So this corresponds to X, and this corresponds to Y. So let me zoom out and hit Apply. And we will have mistakes with our simulation now, but let's try it. Okay, so now I need to show you guys how to reduce lag on your simulations. Now this will depend on what CPU you have and what GPU you have, which graphics card. My specs are an NVIDIA GTX 950M and an Intel integrated GPU. The thing with the GeForce model is that this MATLAB version is not the newest one. So even though I have an NVIDIA GPU, it does lag. So instead I run on my Intel CPU. To do that, you want to first type in OpenGL info. It says I'm using the NVIDIA card, as you can see here, 950M. Now, let's change that to Intel. So what you should do is type in OpenGL software. Let's try that. And type in OpenGL info again. So now it's switched over to Microsoft, which is my Intel card. And if I zoom out there, your simulations will not lag now. It's now time to run the simulation, so I will just type in CLC there to clear the screen. And I will go back into my model. The first thing I will do is run the Excel file because that loads the MATLAB. I'll run the MATLAB file because that loads the Excel script into your function. Because if you don't run it, it'll just say undefined variable in. To confirm the value of in, let's type in the variable name in, and that'll output the values of time. And if we do the same thing with out, it'll show you the actual force as a function of time. So that confirms that MATLAB has read the values. I'm going to make some space here, scroll the window down. The thing to your right is your scope, and the thing to your left is your simulation VRML builder file. And now I will just move some stuff around to make sure that it all fits. I hope you guys understood that the VR signal expander, because the 0, 0, they correspond to X and Y, right, in MATLAB. In MATLAB they correspond to X and Z, but then we want to make it X and Y. So the output signal indices 1, 2, 1 represents X, 2 represents Y. So what I'm doing essentially is mapping them. If I put that number, it will go to Z, because 2 is Y, correct? Excuse me. So I make it 2 instead, because in VRML builder, Y is positive up, and we want it to match Z in MATLAB. So I hope you guys understood that. If you have any questions, don't hesitate to leave it in the comments below. Hit apply, hit OK. And now let's run the simulation, see what happens. Mind you that the scope will update in real time, so you may have to scale it. So just some pause there. So see that? It's moving down. The height's increasing now. It's going up slowly, slowly, slowly. It moved down initially because the gravity force pulled it down. So it's changing now. It's going up higher, higher, because you can see the graph is moving up. And it is slowing down as time goes up because the height is increasing slower. So our velocity is dropping. And now it's stabilizing here. it goes to about 960, if you see that there quickly. If I change the camera to GoPro, which is closer, you can see the position on your bottom right, and the time is right next to it. So it's dropping pretty quickly now, right? So it's dropping at 600, 500, 400, and so on. Scale it there just to see what happens. It is quite cool. Now, so what you could do is put the graph as a fixed scale so that it'll show it all, and that's your final trajectory there. It's done. It stops at negative 16.52 because that's your final time. And that's it. The simulation works. It moves in X and Y. It doesn't move in X and Z because, I said before, MATLAB does not match VRML builder coordinates. And that's it. Post-processor data. So let's move the output to from your scope into your MATLAB workspace so you can work on it and find values such as maximum height, flight time, and so on. So the first thing I will do is double click on scope, and that will open the scope block. Click on the wheel on your second left, and it should open the window. Go on history and unclick limit data points, because what that will do is only save the last 5,000 points of data. So you want to disable that. And let's save the data to the workspace so you can type in a variable name for it. I will call it TR and leave it as array because that's the simplest mode to work with. Hit apply, hit OK. And now let's rerun the simulation so that it would show all the values there. So it glitched. So that's just showing the first 10 seconds. So that's fine. So I'm going to just confirm that it works. Close scope, run. Rerun simulation. And it should plot scope again. It should calculate the flight time. Excuse me for that. So it has outputted to our workspace. To confirm that, type in TR. So the values to your left is the values of time, and the values to your right are the values of the height. So the maximum height I found was about 960 point so. Now you can write your own MATLAB code and find the exact maximum height, because if I just tell you everything, then it would be like spoon feeding. It is quite simple to work with the MATLAB arrays because you can do a lot of stuff in just a few statements. So that's your maximum height there, and that's it. So the MATLAB has outputted to our workspace, and from there you can go on. You can change the values to something you want, and then we can go from there. So that's it for the most part of my video. That concludes part 2. And yeah. So, yep. I would like to conclude by saying thank you all. To anyone studying college aerospace or mechanical engineering, I do hope you found this video useful. The fundamentals of MATLAB are very important in aerospace because almost all aero companies use MATLAB for guidance and control, as well as modeling and simulation. If you have any questions or comments, don't hesitate to leave them below. I know that my teaching skills are not the best because I hope to improve them in the coming months. I've not made a video in a long time, so I'm a bit out of touch. I will plan on uploading a lot more videos this year, so stay tuned. If you want more tutorials on engineering, MATLAB, as well as CFD and CAE, subscribe. Thank you very much, everyone. Bye.